Let's talk about stem and leaf displays and histograms. Do Super Bowls tend to be blowouts, like the Bears' 46-10 victory over the Patriots in Super Bowl 20, or are those the exception? We could look at the data. Here are the margins of victory in the first 49 Super Bowls. Okay, it's kind of difficult to see when the data are expressed like this. It's easier to answer the question if we group the data rather than looking at dozens of numbers. First, we organize the data by constructing a stem and leaf display, or a stem and leaf plot, or a stem and leaf diagram. Okay, the smallest margin of victory was 1. It was New York Giants over the Buffalo Bills in Super Bowl 25 when Scott Norwood missed that last-minute field goal. Largest margin of victory was 45 the previous year. San Francisco 49ers demolished the Denver Broncos 55-10 in Super Bowl 24. So the margins of victory range from 1 to 45. Here's how we construct a stem and leaf display. On the left goes the first digit of the margin of victory. We go through the list from beginning to end, entering the data in the table. So again, here we've got, okay, so you got 25, 19, 9, 16, 3, etc. So here's how we enter it. We put a 5 there because the first digit is 2 and the next digit is 5. The next number we enter is 19. So because the first digit is 1, we put it in that row. So 1, 9. Next number is 9, so that would be 0, 9. We'll put it in the 0 row. Next number is 16. So we put that 6 there. Again, the first digit is 1 and the second digit is 6. Next margin of victory is 3, so we'll put that in the 0, 3 row. Okay, next is 21, so we put that in the 2 row. That's basically the 20s row, 2, 1. And then we've got 0, 7. Next comes 17, so that goes 1, 7. Next comes 10, so that would be 1, 0. Next is 4, so that goes 0, 4. And we just keep doing this. When we're done, this is what we end up with. This is our stem and leaf display. So basically, the stem is the 0, 1, 2, 3, 4, and the leaves, well, those are on the right. So we can use this to generate what's called a frequency histogram. So here we've got, again, the margin of victory. And 0 to 9, there were 19 Super Bowls. 10 to 19, there were 18 Super Bowls. 20 to 29, there were 7 Super Bowls. 30 to 39, there were 4 Super Bowls. And 40 to 49, that was the margin of victory in 1 Super Bowl. Let's use this to construct a histogram. Now, a histogram is a graph like the bar graph that we saw in the last chapter. And here's what we have. Okay, so notice the histogram, this is the 0 to 9. This is the 10 to 19. This is the 20 to 29, 30 to 39. And then there was only 1 Super Bowl that had 40 to 49 as a margin of victory. Okay, so Excel and SPSS can do this. To make a good histogram, make sure that each piece of data fits into exactly one class. Can't do double duty. The classes have equal width and do not overlap. So this is 0 to 9, 10 to 19, etc. And they're between 5 and 20 classes. So you don't want to just have 2 classes. That would look dumb. So here we've got 5. Histogram, it's easy to confuse this. Histogram is like the bar graph or bar chart we saw earlier. But a bar graph has categorical data. The data are categorical, whereas the histogram, the data are quantitative, like the margin of victory of Super Bowl. The horizontal axis can't be a category or time. That would be a bar graph. So let me show you an example. Here's a bar graph which shows the frequency with which letters are used in the English language. So notice the most common letter is E. Next most common is T, etc. Okay, this is not a histogram. This is a bar graph because the categories, the data are categorical. So we don't call it histogram, we call it a bar graph or a bar chart. Here's a bar graph which shows the growth of the U.S. population in recent years. So again, we started off at 301.23 million around 2007, and nowadays we're around 321.565 million. So again, this would be a bar graph. It's not a histogram. Histogram has quantitative data, whereas years aren't really quantitative.